This is the second half of sex-linked traits. Now we're going to use those genotypes into Punnett square problems. So first, let's figure out genotypes one more time and do another example. So hemophilia is a recessive X-linked trait. For the following genotypes, would they A, first be males or females, and then B, determine if they are normal, carriers, or have hemophilia? Remember, only females can be carriers because carriers are heterozygous for a recessive trait. So if you're a male, you're either just going to be normal or have hemophilia. So our first example here is X with a dominant H and X with a recessive H. So first, I see XX, and that would tell me it is a female. Next, it has one of the normal dominant letters or alleles, and it has one of the recessive alleles. So that means they are normal, they don't have hemophilia, but they are able to pass it on, so we call those carriers. The next one is XY. So that tells me right away, XY, it must be a male. So I want to know, are they normal or do they have hemophilia? And in this case, their X carries the recessive allele. And with males, it's a one and done. If you have one of the recessive alleles, you have hemophilia. So this would be a male with hemophilia. XX, so right away that tells me female. And both of these X's have a capital dominant normal allele. So if I have two normal alleles attached to two X's, I would have a female without hemophilia. XY, again, right away, I know the gender. And in this case, the X carries a capital H. And capital is that normal, no hemophilia. So this would be a male without hemophilia. Last one, XX, tells me right away that is a female. And both of those X's carry that recessive allele. So this is the only way that a female would show a recessive sex-linked trait, is if both of the X's carry that recessive allele. Okay, let's put this into a Punnett square problem. So we're going to stay on hemophilia, which is X-linked recessive. So let's say the mother is heterozygous. She's a carrier, but she doesn't have it. And the father does not have hemophilia at all. So he has an X with a dominant H. I want to figure out what % chance will their son have hemophilia and what % chance will their daughter. So with these, we're going to set them up the same way we did blood types. I'm going to take this and spread it over the top. So I have an X with the dominant H there and an X with the recessive H here. So again, I'm writing both the X or Y plus the H on the X. For the male, I'm going to do the same thing on the other side. I'm going to split it across. So I have the X and the Y, and with the H, I'm going to attach it to the X. And just like blood types and Punnett squares in general, I'm going to fill down and across. In this case, the X is always going to go first. And if I have two X's and one of them is capital and one is lowercase, the capital still gets listed first. So if I fill this in, it should look something like this. Here I've got the female options. If they have a daughter, their daughter could be this, or their daughter could be this. And on the bottom, I have the male options because these are the XYs. Their sons could be one of these two genotypes. So first, let's look at the sons, the bottom two here. X with a capital H and a Y, that would be a son who does not have hemophilia. He has the normal allele. This would be a son who does. Now, what % chance will their son have of having hemophilia? That's 50-50. I'm not looking at all four boxes. I'm just looking at the options for the son when I figure out this problem. For daughter, I'm going to do the same thing, only I'm going to focus on just those top two boxes. Okay, so right here I have a daughter who is totally normal. She has two dominant normal alleles. Over here, I have a daughter who doesn't have hemophilia, but she could pass it on because she has that recessive one, so we call her a carrier. So what % chance will their daughter have hemophilia? That's 0%, but there is a 50% chance that their daughter could be a carrier. Okay.